Welcome students to the trigonometric chapter again. Let us deal here with trigonometric identity problems. In order to solve trigonometric identity problems, you have to remember the trigonometric identities thoroughly well and also use algebraic identities to a large extent, such as a plus b whole squared, a minus b whole squared, a squared minus b squared is equal to a plus b into a minus b. All this will be helpful to you to a greater extent in solving these problems. Now, sine squared theta plus cos squared theta is equal to 1. 1 plus tan squared theta is equal to sec squared theta. 1 plus cot squared theta is equal to cosec squared theta. Now, the derivatives from these formulae, you get 1 minus sine squared theta is equal to cos squared theta. 1 minus cos squared theta is equal to sine squared theta. Also, from 1 plus tan squared theta is equal to sec squared theta minus 1 is equal to tan squared theta, sec squared theta minus tan squared theta is equal to 1. Also, from 1 plus cot squared theta is equal to cosec squared theta minus cot squared theta is equal to 1. Also, cosec squared theta minus 1 is equal to cot squared theta. Also remember 1 by sine theta is equal to cosec theta, 1 by cos theta is equal to sec theta, 1 by tan theta is equal to cot theta, 1 by cot theta is equal to tan theta. And now let us deal here with some of the problems for your long-term exercise. In the first slide you see the problem sin a minus 2 sin cube a divided by 2 cos cube a minus cos a, we must prove that it is tan a. Now, we have to convert everything on LHS and bring it to tan a on RHS. So, we have to play with sine and cos formulae to get to that. In the numerator, sin a is common. So, if you take sin a out, sin a into 1 minus 2 sin squared a by cos a into 2 cos squared a minus 1 becomes sin a within bracket 1 minus 2 into 1 minus cos squared a, since sin squared a is equal to 1 minus cos squared a. And in the denominator, we leave it as it is, cos a into 2 cos squared a minus 1. And the numerator becomes sin a into 2 cos squared a minus 1 by cos a into 2 cos squared a minus 1. So 2 cos squared a minus 1 in the numerator cancels 2 cos squared a minus 1 in the denominator. Therefore, we have sin a cos a, which is equal to tan a. Now in the next slide, we have sin a minus cos a plus 1 divided by sin a plus cos a minus 1 is equal to. Now, we have to divide each numerator and denominator by cos a. Then you get tan a. Sin a by cos a minus cos a by cos a plus 1 by cos a in the numerator takes it to tan a minus 1 plus sec a. And in the denominator, sin a by cos a plus cos a by cos a minus 1 by cos a takes it to tan a plus 1 minus sec a. That extends to tan a plus sec a minus 1 by tan a minus sec a plus 1. Now you have the formula 1 plus tan squared a is sec squared a. Therefore, in the denominator, we take tan a minus sec a plus sec squared a minus tan squared a for that 1. So that extends the denominator to minus sec a minus tan a plus sec a plus tan a into sec a minus tan a. That is a plus b into a minus b is a squared minus b squared. And in the numerator we have tan a plus sec a minus 1. And in the denominator sec a minus tan a taken out of the bracket, you get sec a plus tan a minus 1. Therefore, tan a plus sec a minus 1 in the numerator cancels sec a plus tan a minus 1 in the denominator, which gets us to 1 by sec a minus tan a. In the third slide, you have cosec theta minus sin theta multiplied by sec theta minus cos theta should be proved as cos theta sin theta. Now you have to convert everything into sin cos form to get to cos theta sin theta on RHS. The cosec theta is 1 by sin theta, therefore if we take cosec theta as 1 by sin theta minus sin theta, and sec theta we take as 1 by cos theta minus cos theta. 1 minus sin squared theta by sin theta multiplied by 1 minus cos squared theta by cos theta is equal to cos squared theta by sin theta multiplied by sin squared theta by cos theta. Since we know 1 minus sin squared theta is equal to cos squared theta, and then 1 minus cos squared theta is equal to sin squared theta, therefore cos squared theta by sin theta multiplied by sin squared theta by cos theta. That cancels cos theta in the denominator and sin theta in the numerator, giving us the result cos theta multiplied by sin theta on RHS. The next problem below, 1 plus tan theta plus cot theta is equal to cos theta plus sin theta. We will have to prove that. Now we convert tan and cot into sin cos form. Therefore, 1 by sin theta by cos theta plus cos theta by sin theta is equal to 1 by sin squared theta plus cos squared theta by cos theta by sin theta, taking LCM on the denominator. That takes cos theta sin theta to the numerator, and in the denominator we have sin squared theta plus cos squared theta. Therefore, sin squared theta plus cos squared theta is equal to 1. Therefore, the result is cos theta sin theta. Now in the next slide, in problem 5, cot theta minus cosec theta whole squared is equal to 1 minus cos theta by 1 plus cos theta. We have to prove on the RHS 1 minus cos theta by 1 plus cos theta from cot theta minus cosec theta whole squared. Coming to LHS, we have to convert everything into cos sin form. Therefore, cot theta is equal to cos theta by sin theta, and cosec theta is 1 minus sin theta. Therefore, cos theta by sin theta minus 1 by sin theta whole squared is equal to cos theta minus 1 by sin theta whole squared, because the denominator is common. Therefore, cos theta minus 1 whole squared by sin squared theta is equal to cos theta minus 1 into cos theta plus 1. Since a squared minus b squared is equal to a plus b into a minus b, then sin squared theta is equal to 1 minus cos squared theta. Therefore, the denominator, applying a squared minus b squared, same formula, a plus b into a minus b, denominator also becomes 1 plus cos theta into 1 minus cos theta. So, reversing sign on the numerator, we have minus 1 multiplied by 1 minus cos theta multiplied by cos theta minus 1. So the denominator is 1 plus cos theta into 1 minus cos theta. It cancels 1 minus cos theta in numerator and denominator. Then minus 1 into cos theta minus 1 is equal to 1 minus cos theta in the numerator, and the denominator remains 1 plus cos theta. Therefore, we have proved 1 minus cos theta by 1 plus cos theta is RHS. In problem 6, we have to prove 2 sec squared plus 2 cosec squared theta by sin squared theta plus cos squared theta is equal to 2 sec squared theta cosec squared theta. Sec squared theta cosec squared theta is always the extension of the family of sin theta and cos theta. Therefore, we play within sin and cos to get the results. Therefore, 2 by cos squared theta plus 2 by sin squared theta by sin squared theta plus cos squared theta gets it extended to 2 sin squared theta plus 2 cos squared theta by cos squared theta sin squared theta in the numerator, and sin squared theta plus cos squared theta is in the denominator, remains the same. In the next step, we take common 2 out. Therefore, 2 sin squared theta plus cos squared theta by cos squared theta by sin squared theta, and while dividing it by the denominator sin squared theta plus cos squared theta, sin squared theta plus cos squared theta goes up. So 2 into 1 into 1 by cos squared theta by sin squared theta will be the result. 1 by cos squared is again sec squared, 1 by sin squared is again cosec squared. Therefore, 2 sec squared cosec squared theta is RHS proved. In the next slide, problem 7, we have cos squared theta by 1 minus tan theta plus sin cube theta by sin theta minus cos theta to be proved as 1 plus sin theta cos theta. On RHS you have sin theta cos theta, therefore convert LHS into sin theta cos theta form. Therefore LHS taking LCM of the denominator, we have cos squared theta by 1 minus sin theta cos theta plus sin cube theta by sin theta minus cos theta. Gets it extended to cos squared theta by cos theta minus sin theta by cos theta plus sin cube theta by sin theta minus cos theta. In the next step, cos cube theta by cos theta minus sin theta plus sin cube theta by sin theta minus cos theta. Multiplying the denominator, sin theta minus cos theta by minus 1, it changes to cos theta minus sin theta. Therefore, the denominator is made equal. Therefore, cos cube theta minus sin cube theta, that changes the sign, by cos theta minus sin theta into cos theta minus sin theta. Therefore, cos cube theta minus sin cube theta by cos theta is equal to a cube minus b cube, which is equal to a minus b into a squared plus b squared plus ab by formula. Therefore, let us take cos theta as a, sin theta as b. Therefore, we get cos cube theta minus sin cube theta down to cos theta minus sin theta multiplied by cos squared theta plus sin squared theta plus cos theta sin theta. Cos theta minus sin theta in the numerator cancels cos theta minus sin theta in the denominator. So we get cos squared theta plus sin squared theta is equal to 1. Therefore, 1 plus sin theta cos theta is proved as RHS. Next slide, problem 8. Convert LHS into sin theta cos theta form. Therefore, cos theta by sin theta minus sin theta by cos theta gets it to cos squared theta minus sin squared theta by sin theta cos theta. Then sin squared theta is also 1 minus cos squared theta. Therefore, in the next step, we get cos squared theta minus 1 minus cos squared theta by sin theta cos theta is equal to 2 cos squared theta minus 1 by sin theta cos theta. Then we get the problem tan squared theta minus sin squared theta is equal to tan squared theta sin squared theta. Tan squared theta is sin squared theta by cos squared theta minus sin squared theta, which is equal to tan squared theta sin squared theta. Taking LCM on the LHS, then we get sin squared theta minus sin squared theta cos squared theta by cos squared theta, which gets it extended to sin squared theta minus sin squared theta into 1 minus sin squared theta for cos squared theta divided by cos squared theta. Therefore, sin squared theta, if you take as common factor, then sin squared theta within bracket 1 minus sin squared theta you get. Therefore, in the numerator, sin squared theta into 1 minus 1 plus sin squared theta cancels 1. Therefore, sin squared theta into sin squared theta by cos squared theta we get. Sin squared theta by cos squared theta becomes tan squared theta. Sin squared theta remains the same. Therefore, it is tan squared theta sin squared theta. Then in the next slide, problem 9, we have 1 by cosec theta minus cot theta minus 1 by sin theta is equal to cot theta. Becomes cosec theta plus cot theta by 1 plus cot squared theta, which is cosec squared theta, minus cot squared theta, then minus 1 by sin theta. Then in the next step, cosec theta plus cot theta, cot squared theta minus cot squared theta getting cancelled, denominator becomes 1, minus 1 by sin theta. Therefore, taking LCM, on the numerator, 1 by sin theta plus cos theta plus sin theta divided by 1 by minus 1 by sin theta. That gets us to 1 plus cos theta by sin theta minus 1 by sin theta. The denominator being common, 1 plus cos theta minus 1 by sin theta is equal to cos theta by sin theta, which is equal to cot theta. In problem 10, we have cos square theta by sin A plus sin A is equal to cosec A. Taking LCM, we get cos squared A plus sin squared A by sin A is equal to 1 by sin A. Since cos squared A plus sin squared A is equal to 1, then 1 by sin A becomes cosec A. That is proved. And in the next slide, we get to sin A plus cos A by sin A minus cos A plus sin A minus cos A by sin A plus cos A should be proved as 2 by 1 minus 2 cos squared A. Taking LCM, we get sin A plus cos A whole squared plus sin A minus cos A whole squared by sin squared A minus cos squared A. Extending that with A plus B whole squared formula, A minus B whole squared formula and A squared minus B squared formula, we get the numerator as sin squared theta plus cos squared theta plus 2 sin A cos A plus sin squared theta plus cos squared theta minus 2 sin A cos A by sin squared A minus cos squared A. Sin squared theta plus cos squared theta being 1, you get 2 in the numerator, 2 sin A cos A getting cancelled, and in the denominator we have sin squared A minus cos squared A. Also, sin squared A is equal to 1 minus cos squared A. Therefore, 1 minus cos squared A minus cos squared A in the denominator takes us to 1 minus 2 cos squared A. Numerator is 2. Then RHS is proved. Then in the next slide, cos A by 1 plus sin A plus 1 plus sin A by cos A must be proved as 2 sec A. Taking LCM, cos squared A plus 1 plus sin A whole squared by 1 plus sin A multiplied by cos A extended to cos squared A plus 1 plus sin squared A plus 2 sin A by 1 plus sin A multiplied by cos A. Cos squared A plus sin squared A is equal to 1. Therefore, the numerator becomes 2 plus 2 sin A by 1 plus sin A multiplied by cos A. Gets it extended to 2 being common factor taken out 2 into 1 plus sin A by cos A into 1 plus sin A. Numerator and denominator 1 plus sin A gets cancelled. Therefore, 2 by cos A is equal to 2 sec A RHS. In problem, we have cosec theta by cosec theta minus 1 plus cosec theta by cosec theta plus 1 is equal to 2 sec squared theta. Taking LCM, cosec theta into cosec theta plus 1 plus cosec theta into cosec theta minus 1 by cosec theta minus 1 into cosec theta plus 1. A plus b into a minus b formula takes the denominator to a squared minus b squared. Therefore, cosec squared theta minus 1 is the denominator, and in the numerator, removing the brackets, we have cosec squared theta plus cosec squared theta minus cosec theta. Minus cosec theta plus cosec theta getting cancelled. Then we get in the numerator 2 cosec squared theta by cosec squared theta minus 1. Then we know cosec squared theta is 1 plus cot squared theta. Therefore, in the denominator, for cosec squared theta, we have 1 plus cot squared theta minus 1. Numerator remains the same, 2 cosec squared theta. Then cosec squared theta, then it becomes 2 cosec squared theta by cot squared theta. Cosec theta is 1 by sin theta. Therefore, numerator becomes 2 by sin squared theta. Denominator becomes cos squared by sin squared theta. And dividing both, you get 2 by sin squared theta into sin squared theta by cos squared theta. That takes us to 2 by cos squared theta, which is equal to 2 sec squared theta. Thank you.